Alright, in this video I'm going to demonstrate how we apply the NPV rule, or not the NPV rule, the calculation of the present value of uneven cash flows. There's an Excel function called the NPV function that does this, and the NPV sort of stands for uneven cash flow present value. Joe wants to earn 10% on his investments, and the Magic Bean salesman offers him an investment deal, Plan A, which will give him $500 in the first year, $500 in the second year, $500 in the third year, $2,500 in the fourth year, and $8,000 in the fifth year. And the cost of this is $8,250. Well, the grand total of the money you would pull in, if we sum up all these cash flows, that's $12,000, right? So you get back, you invest $8,250, you get back $12,000. Does that earn a rate of return equivalent to 10% for Joe? Okay. We could calculate what the fair value that Joe assigns to a set of cash flows like that by taking the present value. Alternatively, the Magic Bean salesman says, hey, tell you what, Joe, I'll guarantee you $2,200 a year for 5 years, and that'd be $11,000 for the same price. Well, I can calculate the present value of $2,200 per year for 5 years using my the functions we've been using so far: number of periods, rate, present value, future value, and PMT. So Joe would have to give up $8,250. Well, I'm going to calculate the present value of this, so I'm going to calculate what it's worth. This series of cash flows here, if the present value is equal to $8,250, no harm, no foul. So let's calculate the present value. Alright, so this would be 5 payments. 10% is the rate of return he expects to earn. So he's getting $2,200, and then he doesn't get anything after that. So the fair value to Joe on that would be the present value, or that'd be the fair price. 10% is what he requires, 5 periods, payment, future value, hit the OK button, and that's worth $8,340 to Joe. And the salesman's offering it for only $8,250. So that ain't a bad deal at all, right? So he likes that plan, but it actually earns less than this plan. Trouble is, I can't calculate the present value of this mess because the PMT is different. Now, I could calculate the present value of each of the cash flows, but the easier way to do this, if I want to know what the present value is, and on this one, the present value is $8,340. There's the NPV function. Now, the NPV function in Excel, you just have to type in equals NPV open parens. The discount rate, here it's 10%, and then cover up cash flows 1 through N. Okay, and so after doing that here, what I find is that the fair value of this set of cash flows is only $7,918. By the way, I could have used the same function over here. It'll come up with the same answer. The difference in the cash flows, this is less total dollars, but you get them back sooner. So you could reinvest them sooner, so they'd start earning interest sooner. So that makes them more valuable. So if Joe had a preference between these two, Plan B, it would definitely be worth $8,250. Joe would actually be willing to pay up to $8,340 for it. But this set of cash flows is only worth $7,918 to him, so he wouldn't buy it. That's how we use NPV analysis. It's NPV for uneven present value cash flows. You can calculate the present value of a series of payments that are uneven. All right. Now you can use the PV function on Plan B because each of these payments is the exact same amount at each of the ends. But you can't use the PV function when the payments are uneven. But that's where the NPV function comes in. So the function is NPV, the interest rate, and then the cash flows. Fairly simple formula.